Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky the week of September 8th. This time around, the moon is tough to start the week. Gets a little better by the end of the week. But the moon has a couple interesting events. It starts full, just less than full, over 95% full on the night of the 8th into the morning of the 9th. And it sits about 6 degrees northeast of Saturn. So you got Saturn, Neptune, and the moon there to start the week. So that should be fun to get out and observe. Then later in the week, the evening of the 13th into the morning of the 14th, the moon's about half full. And for some observers, the moon will occult Elnath, a big bright star. We love Elnath. We talk about it all the time. It's the end star in the big V that marks Taurus the bull right there. And so that's Elnath. And for some observers in the southwestern part of the United States, the moon will pass right over the top of Elnath. For the rest of us, for me here in the middle of the United States, the moon will get very close to Elnath, but it's going to be daylight. I think I'm a little too far north anyway for the angle to be right, but it's going to be daylight before this occultation occurs. It'll be about 7:30 to 7:45 my time, which means 6:30 to 6:45 for some people west of here, and then farther west, maybe the Phoenix area, 5:30 to 5:45. So that's something to look for, is this occultation of a bright star. A bright star we talk about all the time because it lies on the ecliptic. And so things like this can happen. Planets are near there. The moon is near there frequently. And the moon's going to pass right over the top of it. So that's great. In the big glow of the moonlight early in the week, we can still observe double stars. So we'll just bring your attention. We've done this before, but we'll bring your attention to the famous double-double, Epsilon Lyrae. Epsilon Lyrae sits just off of Vega. Vega's the big bright star, part of the summer triangle, right? That sits above the parallelogram that forms the body of Lyra. And so just up and sort of north and east there too of Vega would be Epsilon Lyrae. And it's about a 5th magnitude star, just below, just brighter than 5th magnitude. So it's actually a fairly visible star if you got dark skies. The two stars, it's a double star. And it's the two components are separated. They're about 2 5th magnitude, 5.1 magnitude stars that are separated by 3.5 arc minutes. That's a huge separation. Okay, so this is a big separation that's easy to see. But each of those components is also a double star that's separated by about 2.5 arc seconds. So you've got a binary star in each case there. 5.1 magnitude primary components of each, 6 magnitude and 5.4 magnitude companion. So you get a nice 4 dots of light in your telescope. So this is something you can do early week while the moon's washing a lot of stuff out. This is the summer triangle is well placed as it gets dark and easy to see. So Vega should be. Vega's up all night. I see it in the morning when I get up. So Vega's well placed for observing just after dark, but it's there in the still setting in the west in the morning when I get up. So let's turn our attention then to something else later in the week as the moon starts to rise later and later and wanes toward half full or a third full by the very end of the week. We've got look for objects in the evening sky that we'll be able to see. And the Great Square of Pegasus is one of those things. It tells us that it's fall, right? So we see the Great Square of Pegasus rising into the sky, already well placed for observing by the time it gets dark. By the time good darkness falls, 8:30, 9 o'clock at night for me here right now. And so you've got the big square of Pegasus. You've got this arm. Horses don't have arms, but let's not worry about that. That comes off this side and angles up. And the end of that chain is Epsilon Pegasus. We look at Epsilon Lyrae here. This is the Epsilon star in Pegasus, Enif, it's known. And if you just extend that on out, that about 4 degrees, you got M15, a nice globular cluster. Your binoculars should show you that. You got your smart telescope to take photographs. You're going to get a big, beautiful photograph of that. Any eyepiece you got, any telescope you've got, should be able to give you a nice view of M15. You drop 12.5 degrees, basically straight south, and you get to M2, another example of a great globular cluster that you can observe in a small telescope. You can photograph. Probably you can see it in your binoculars. So you see these two beautiful examples of globular clusters. Not a lot of globular clusters in this part of the sky. On this direction, you've got a lot more globular clusters, but this is the outer edge of the distribution. This part of the sky is known for galaxies, and we don't see a lot of galaxies near globular clusters, but we do here with these two big bright examples of globulars. The reason for this is our galaxy. The center of the galaxy is here. We're in this flattened disk. The disks of all spiral galaxies, the disk of our galaxy has a lot of dust and gas and cold molecular gas and dust, hard to see through. It obscures objects you don't see very far. And to see the globular clusters, we largely have to look toward the center of the galaxy down that flattened disk. And this doesn't work very well for us, right? We just don't see much in that region of the sky. If we want to see out into deep space to see galaxies, we can't. We can't see through our galaxy to see galaxies. To see galaxies, we want to look through the thin part of the disk, this direction or this direction. But if you have globular clusters that are out on this near edge and out away from the very center of the galaxy, so up high and out on this edge, we can look up that direction. We can see galaxies and a few globular clusters as well. And so that's what we're doing right here. That's the geometry we've got, is we're looking at the near edge of the distribution of globular clusters. And so it's out toward us, but it's also not directly toward the center of the galaxy. It's up out of the disk of the galaxy a fair bit. That allows us to see, we're not looking through so much local material that we can still see external galaxies. So this region is rich with external galaxies. The first one we're going to point out is next to Markab here, the lower right star in the corner of the Great Square. It's the Alpha star in Pegasus, right next to Markab. Let's come back to that. Let's do that one in a second. Let's actually do the hard one first, Enif. Let's go back here to Enif, that was our guide star to M15, and let's do that one. Save the good object for the end. Enif is our real challenge object. About 50 arc minutes, I think, less than a degree from Enif, sort of off again to the northeast. Is galaxy NGC 7132, but wow, is this a faint, challenging galaxy to see. If you want to see it in your eyepiece, I'm going to guess you want a 20 or 24-inch diameter telescope. You want a big telescope, and you want good dark skies to be able to see that galaxy as a faint smudge of light. It's easy enough to photograph because it's so close to Enif. You can get Enif down in one corner of the field of view typically and find the galaxy up here, or you can slide around and poke a little bit. So if you have a smaller telescope and you want to be taking photographs, that's your challenge object for the week, is to see if you can find galaxy NGC 7132. Now back to Markab, the Alpha star in the Great Square of Pegasus. If you drop straight south from there about 3 degrees, finger at arm's length recall is about 1 degree. You drop about 3 degrees straight south, you get to NGC 7479, another galaxy, sometimes called the Propeller Galaxy, very different from NGC 7132. This is a fine object to observe. My guess is you could see it in a 3 or 4 inch telescope if you got really good, clear, transparent skies. But a 6 or 8 inch scope is going to be a lot better for you. So you got a 6 or 8 inch scope, use your lowest power eyepiece, use your 30 or 40 millimeter eyepiece, 50 millimeter eyepiece maybe, get a nice low power and find it, and then you can dial the magnification up to try to get a closer look at it. This is a barred spiral galaxy. So barred spirals have 2 main spiral arms and a large central bar across the middle. But in addition to be a barred spiral galaxy, it's also something of a starburst galaxy, a star formation galaxy, and it's also what we know as a Seyfert galaxy, and those two things often don't combine. They do sometimes because the Seyfert galaxy means it has an active galaxy. It's got an active central black hole that's got gas, and it's emitting radiation in there. So this is an active galaxy, but it's also got heavy star formation in the central part of the galaxy, and a lot of spiral galaxies don't. Our galaxy does not have star formation going on in the central part of the galaxy, the central bulge, only in the disk. But this has a lot of star formation going on in there, and this often happens because of an interaction with another galaxy, but this is a fairly isolated galaxy in space. You don't actually see another galaxy near it. So this is just an interesting galaxy. It's interesting visually. If you see it in your scope, if you got a 10-inch scope or a 12-inch scope, then you can start to see some of the structure and some of the structure that we're looking at here, this nice face-on spiral galaxy. If you take photographs, this is your photographic object of the week. If you really want a pretty photograph to share, see if you can find the Propeller Galaxy and do this here, this barred spiral galaxy. The central bar, again, where all the star formation's going on where we don't typically expect star formation. And with young stars, here's the trick, is young stars, you're making these new stars, you're making low mass stars, a lot of low mass stars, and a few high mass stars, and high mass stars don't live very long. And those are the ones that can become type 2 supernovae. And so if you want to see a lot of supernovae, you want to be in a region where there's young stars. That often is paradoxical to people. They think, well, that's the end of a star's life, and so you don't want young stars. But the very, very massive stars don't live long, and so they reach this supernova state when they're young. And so we've seen supernovae in this galaxy in 1990 and 2009. So that's 2 supernovae in the last 30-some years, 35 years that we've seen right there. And so this heavy star formation allows us to see that. For example, in our own galaxy, we might expect 1 or 2 per century. We don't see them because of all the dust and gas that we talked about. You can't see all those supernovae, but we might see 1 or 2. Whereas in a galaxy like this, we might not see all the supernovae in this galaxy if it's on the far side of this central bar, right? We're not going to be able to see through this central disk. So we're probably missing supernovae in this galaxy as well. But we've seen 2 of them just in the last 35 years. And so this is again a property of it being a star formation galaxy. So that's what we got. This is good stuff this week. Do this late in the week after the moon has waned away and is rising later and later in the evening sky. Get out, see M2, M15, NGC 7132. Good luck. And NGC 7479. These are great objects. Even before the moon has waned away, you can see the double-double, this nice, beautiful binary in Lyra. And then watch for the moon to get very near Elnath. And if you live in the southwestern part of the United States or Mexico, you can probably see this occultation occur. See the moon actually pass right over the top of Elnath. That'll be great. And the moon starts the week near Saturn. So get out and check that out. We got all this stuff, great stuff. It should be a good week ahead. As always, thanks for watching, everybody.